Bismillahirrahmanirrahim, dear student. In this video, we are going to solve some example for the second condition of the equilibrium. Okay, let's see the example for the second condition of equilibrium, and we already know about the second condition of equilibrium. We discussed the second condition, so let's see some question, and now we try to solve one by one. Okay, here in this example, calculate the Turk. Like you know that in the second condition, usually we are going to calculate the Turk in the second condition. In first condition, we like calculate the or find the total forces, and here in second condition we calculate the Turk. Okay, here a weight is hanging which is 10 centimeter away from the pivot point, like this turning point, and also here is a tension force is also given, which is equal to 800 Newton, and make some theta or angle which is equal to 30 degree. So here they want calculate the torque about the pivot point, mean they want to find the here like this point torque. There is no need to find the torque on this point. Like here also, when this tangent force pull this one in this direction, upward direction, so there is also produced the torque, but only they want the torque in this point. So here some weight is given, like this, the mass is given, which is equal to 5 kilogram. So now if this mass pull this beam downward, so there is produced the torque. So they want this torque. Okay, let's see like what they want in the question. Calculate the torque about the pivot point, mean this point marked by x, mean this one due to the hanging mass of 5 kilogram. Okay, we will ignore this part because there is no, they don't ask about this force, only they ask about or want this force. Okay, so here if we see the distance from x and to the weight or mass is equal to 10 meter, this is equal to 10 meter the distance, and the weight is what perpendicular, like the distance and weight is perpendicular. So if we want to find the torque here, so very simple, we know that F is here perpendicular to the distance. Okay, torque is equal to, in this case now the force is equal to weight. Why? Because it is downward. Weight multiplied by d or perpendicular with d. Now weight is equal to m multiplied by g multiplied by d. So let's see again, mass is equal to 5 kilogram, and acceleration due to gravity which is produced 10 meter per second square multiplied by, and the distance is 10 meter. Okay, so if we multiply this two in kilogram in meter per second square, this is equal to Newton, these two value, and like this is mass time acceleration is equal to force. Okay, so let's see again here, if we multiply this is equal to 50 Newton, like kilogram in mass divided by second square is equal to Newton multiplied by 10 meter, and if we multiply these two value, so this will give us 500 Newton meter, which is equal to torque on which point? On the x point, this point. Okay, this is the first example. Let's see the another example of what they want in the next example and how can we find. Okay, and this is also the same example here, like the total distance from this to the end of beam, this is equal to 14 meter. Now in this case what they want, tangent force is applied at the beam of the end, like this one tangent force, and let's see, calculate the torque generated by 800 Newton. Now in this question they want the torque which is produced by this tension force, like when this rope is pull the object upward, so there is produced the torque, mean upward in this direction, there is produced the torque in this direction. Okay, tension at the end of the beam, like the tension force is applied at the end of the, this is beam, and tension force is applied at the end. The pivot point is given to be on the beam next to the wall. Okay, let's see here. Now the tension force, in this part we will find the component of the tension force, like this is the vertical component which is equal to T of y, which is equal to T of y will be equal to how much? T dot sine theta, and this is the T of x, which is equal to T dot cosine theta. Okay, in this case let's see here. Now they want to find the turn because of this force, this one. So torque will be equal to, in this case, F perpendicular to D, mean the total distance is equal to how much? 14 meter. Now in the force in this case is equal to T of y. Only we are focused on the this component of the force, this component of the tension force. Okay, in this case the tension force is equal to T dot sine theta, T dot sine theta multiplied by D, and both are perpendicular distance and T of y is perpendicular. So putting the value here, T is equal to 800 dot or multiplied sine theta is equal to 30 degree multiplied by the distance is 14 meter. Okay, let's see here. If we multiplied 800 multiple sine 30 is equal to like if we multiplied these two value, so this is equal to, this is 800 multiplied by sine 30, so this is equal to 400 Newton multiplied by 14 meter. Now 400 multiplied by 14 Newton, which is equal to 5600 Newton meter. So the total torque produced by the tension force at this point, which is equal to 5600 Newton meter. Okay students, so this is the second example of the second condition of the equilibrium. If you have any types of questions, so you can ask through in your comment. Thank you so much.